Hi there, this is your favorite non-Indian math channel, and let's see how we can evaluate this infinite sum. Well, if we had a telescopic series, which kind of looks like 1 over n plus 1 minus 1 over n, which just you would just have terms simplifying after each step, like so when I put n plus 1 here, it's gonna just subtract with the previous term, and there almost everything will just cancel out, and this is a easy sum. Okay, this is easy sum. But now maybe we can try to make this thing look like that. So let's see how we can do it. Maybe if I could just get rid of this thing, because just I'm multiplying few number of terms, and if I could get rid of this one, and well, I can pretend like there is a 1 here too, so maybe I could work with that. So I'm just gonna multiply this thing 2 by 2 and divide by 2. I'm trying to get to the 2n plus 1. So I add 1 and subtract 1, and so let's rewrite this. This series would be equal to, so n greater equal than 1. So from this thing, everything, the last term would just cancel, and I would have 1 times 3 times up to 2n minus 1. So I just had the last term canceling, and minus, so I have from 3, well, I can also write 1 here, but it doesn't help me to visualize it better. 2n plus 1. Here, why is it helping? Why is it good? If you look, if you put n is equal to 1, like you're just shifting this sum by 1 here, and we will see how this stuff would cancel. But instead, we can't really work with infinite sums like this, so let's define a sequence which is called sk, and sk is gonna be just equal to this thing when it's finite, okay? N is from 1 to k. Instead of adding infinite terms, we just add k terms. So it's just same thing. Okay, I'm not gonna write again. So let's open what do we get? So when I put n is equal to 1, I'm just multiplying stuff 1, and I'm multiplying 1 up to 2 times 1 minus 1, which is just 1. So I only have 1 from this term. And from here, so it's, again, if I put 1 here, it's 3. I'm just multiplying all of this stuff, so it's just minus 1 over 3. And if I put n is equal to 2, it's gonna be 3 here, so I'm multiplying it up to 3, so it's gonna be 1 over 3, 1 times 3. And from here, I'm gonna get 3 times 5. Well, now, and if I just write this term again, it's gonna be 3 times 5, so it's easy to see how they are canceling. So every term are canceling like this, and if I just keep doing this, so I'm doing this up to k. When I put k, it's gonna be 1 over 1 times up to 2k minus 1 minus, so this is gonna be 3, 5 up to 2k plus 1. And this term will also cancel, so therefore sk is gonna be equal to 1 minus this thing, which is 1 over 3, 5, whatever, 2k plus 1. And I know that if I call my sum s, I still didn't know if this was convergent. I only made one manipulation, which was just dividing and multiplying by constants, and it doesn't matter, so I didn't really play with it. And now I will know that it's convergent, because if I take this limit as k goes to infinity at sk, this is going to be equal to my sum, which is s. And so, and if I take limit here, but here also I multiplied it and divided by 2, so my actual goal was to calculate 2s, okay? So I will keep that in mind at the next step, okay? Or let's just say, okay, I will say this is s over 2, because I actually divided my sum with 2. Okay, So here, if I take limits, or I actually didn't, because I took this 1 over 2 at the calculations. If I just write 1 over 2's everywhere, okay, so I have 1 over 2 parentheses everywhere. So this is also 1 over 2 parentheses everywhere. Then now I don't need to deal with that. So s is gonna be just, if I take this limit as k goes to infinity, this thing will just be 0, and this will be just 1 over 2. And this is my answer.